Hi there, and welcome to this lesson. Now, in this lesson, we'll be learning about sets. Okay, we'll be learning set theory, and basically, we'll learn what sets are, and basically, we'll also learn about the properties of sets. We'll learn about Venn diagrams, and finally, we'll learn to solve problems using Venn diagrams. Okay, and as the lesson progresses, if you have any issues at all with any of the concepts, okay, and with the principles unclear, please feel free to get in touch. Okay, you could do so via phone, WhatsApp, Skype, or Facebook, and we would be happy to help. You can also visit our website. We do have a lot of exciting features for you on there. So let's jump right into the lesson. So set theory. Okay, we'll start off with a brief introduction. Okay, introduction to set theory, and basically, what are sets? Okay, so basically a set is a collection of well-defined objects. For example, you have a set A as even numbers less than 10. Okay, or you can have a set B as integers between 5 and 9. All right, basically it's a collection of well-defined objects. Okay, and the members of a set are called the elements of a set. For example, if the same A, basically A has even numbers less than 10, even numbers less than 10, we have 2, 4, 6, and 8. Now, these are the elements of set A. All right. Now, n of A, you could be given an expression like this. N of A denotes the number of elements in set A. For example, you could have A as even numbers less than 10, i.e. 2, 4, 6, and 8. We have 4 elements in this set, so n of A in this case would be 4. Now, two sets are equal if they contain the same elements. For example, if you have that A equals 1, 1, 3, 4, and you have that B is 3, 2, 4, 5, and C is 1, 1, 3, 4. You'd have that set A equals set C because you have the exact same elements in set A as you have in set C. Okay. Now the subsets of a set. Okay, let's talk about the subset of a set. The subsets of a set are sets that are made up of elements from the original set. Okay, and is denoted by this symbol that looks like a C. Okay. Now, basically, if you have a set A as 1, 2, 3, 4, 5, 6, and you have a set B as 1, 3, 5, and you have another set C as 2, 4, 6, something you'd notice is that set B and set C are actually components of set A. Okay, basically the elements of set B are actually extracted from set A. All right, and that would tell you that set A and set C, sets B and set C are subsets of set A. Okay, let's move on. Let's talk about the union of two sets now. Okay, the union of two sets is a third set that contains all the elements of the first two. Okay, and it's denoted by the symbol U. Okay, so it's a union, and I believe that is pretty much self-explanatory, but basically, if you have a set A and set A contains 1, 3, 5 as its elements, I have a set B as 2, 4, 6. Basically, if you bring these two together, you'd form a new set, set C, which would have 1, 2, 3, 4, 5, and 6. And basically, you have that set C is A union B. All right. Okay. Bringing the two sets together, unifying the two sets. Okay. So let's talk about the intersection of two sets. All right. Now, the intersection of two sets is a set that is made up of elements that are contained in the first two sets. Okay, it's denoted by the symbol. It looks like an N. All right. For example, you could have that A is a set that contains 2, 3, 5, and 7, and you could have that B is another set that contains 1, 3, 5, 7, and 9. Now, C is a set that contains 3, 5, 7. What you notice is that C is an intersection of set A and set B, i.e., if you notice, you have the elements that occur in, let's draw this up. Basically, you have elements that occur in A that also occur in B. That's basically what the intersection is about. So elements that occur in A, we have 3, 5 and 7. Okay, these are the elements that occur in A and occur in B as well. Okay, and let's move on. Basically, these are just very simple principles. And given a universal set, okay, and I'll just tell you what a universal set is. A universal set is a set that contains all the elements, okay, and that's all you need to know for now. It will be clearer as we progress. But a universal set is a set that contains all the elements, okay. A complement of a set is a set that is made up of elements that are not contained in the set but contained in the universal set, okay, and it is denoted by the symbol A prime. For example, you could have a universal set, okay. A universal set is, you can have a universal set as 1, 2, 3, 4, 5. That's numbers between 1 and 9, okay. And basically, I can have a set A containing elements from the universal sets, okay. So we have 2, 3, 5, and 7. Now, A prime would be elements contained in the set A, elements that are not contained in the set A but are in the universal set, okay. And basically, what we have is we have 1, 4, 6, 8, and 9. All right. And finally, an empty set is a set that contains no elements. All right, and it is denoted by the symbol. This basically it's an O with a stroke, okay. And that is pretty much all we need to know about sets, okay. So basically, we've learned about the members of a set, we learned about subsets, the union of two sets, the intersection of two sets, and the complement of a set. All right, and I think we can go on and solve some examples now, okay. So example 1. And example 1 says, given that A equals 1, 2, 5, 7, okay, and B is a set containing 1, 3, 6, 7, and C is another set containing 2, 5, 6, 9, okay. These are subsets of a universal set, okay. Now this looks quite complicated, but it's actually really simple, okay, and I'm just going to teach you how to read this, okay. These are subsets of the universal set. So this equals integer x 0 less than x less than or equals to 10. Okay, so now this first part tells you that x is an integer. Okay, so it tells that there are no decimals in this set, there are no fractions in this set. So basically this set is made up of numbers like 1, 2, 3, 4, 5. Okay, so that's what the first part tells you. And then this is a range. Okay, whenever you see this, you know it's a range, and what it simply tells you is that x is between 0 and 10. Okay, x is greater than 0 and x is less than or equals to 10. Okay, something else you need to be mindful of: since x is greater than 0, it tells you that 0 is not a part of this set. Okay, but x is less than or equals to 10. So basically we have all the numbers up until 10, okay, including 10, because x is less than or equals to 10. Okay, so basically x is greater than 0 and x is less than or equals to 10. It tells you that the numbers you have 1, 2, 3, 4, 5 up until 10. Okay, and now we've been asked to solve for A prime. Okay, we've been asked to solve for A intersect B prime, or close bracket prime, and we've been asked to solve for A union B intersect C. And let's just go ahead and do that. So the first thing we do here, basically we have that A is, the set A is 1, 2, 5, 7, okay, and A prime would be elements that are not in set A but are in the universal set. And remember, the universal set contains elements 1 to 10. Okay, so elements that are not in A but are in the universal set, and we have 3, 4, 6, 8, 9, and 10. Okay, let's move on. So the next thing we want to do here, we're looking for A intersect B prime. Okay, so we have the complement of A intersect B, and basically we have that A is 1, 2, 5, 7, okay, and B is 1, 3, 6, 7. Okay, now A intersect B is 1, 7. Okay, so the elements you find in A that you would find in B as well. Okay, that's A into the intersect of A and B, we have 1 and 7. Okay, and basically to find A intersect B prime, we basically look for elements, the complement of A intersect B, we basically look for elements that are not in A intersect B but are in the universal set, and we have 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so that is A complement of A intersect B. Now the next thing we do, okay, we're looking for A union B intersect C. Okay, and we have that A is 1, 2, 5, 7. We have that B is 1, 3, 6, 7. And we have that C is 2, 5, 6, 9. Okay, let's go through this. So A union B, that's bringing A and B together. We have 1, 2, 3, 5, 6, and 7. And let's take note of something here. When you solve for the union of two sets, you do not repeat terms. Okay, so basically you want to bring these two sets together, and if you bring them together, you actually have 1, 1, 2, 3, 5, 6, 7, 7. Okay, but then when you're solving for the union of two sets, you don't do repetitions. Okay, so you just have just 1, 1 and a single 7 as well. So a single 1 and single 7. So A union B is 1, 2, 3, 5, 6 and 7. Okay, and the next thing we want to do, we want to find A union B intersect C. So we have A union B, and what we need to do is we need to find elements that are in A union B and that would also find in C. Okay, and looking at that, I'll tell you that you have 2, 5 and 6. Okay, and that is how you solve a question like that. Okay, let's move on. I have another example here. Let's move on to the next example, example 2. And example 2 says, given that A equals 1, 2, 5, 7, 8, and B equals a set that contains 1, 3, 6, and 7, and these are subsets of the universal set, this equals integer x, 1 is less than or equals to x, which is less than or equals to 9. Illustrate the information using a Venn diagram. Okay, so let's get our pointer out. Okay, so this is A, this is B, and these are subsets of the universal set this. Okay, so this is also an integer, x is an integer, and x is a range between 1 and 9. So we have 1, and basically we have x is less than or equals to 1, which means our range would include 1. And x is greater than or equals to 1, which means our range would include 1. And x is less than or equals to 9, which means our range would include 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we've been asked to illustrate this information using a Venn diagram. All right, and we just go ahead and do that. Venn diagrams. How do you draw Venn diagrams? Okay, let's see how all of that works. All right, so to draw a Venn diagram, basically we draw a rectangle, okay, and this rectangle represents the universal set. It covers everything, okay, and we'll just bring in the symbol for universal set there. Okay, so this rectangle represents the universal set, and everything, all the elements involved here would be inside this rectangle. Okay, and next thing we have two circles, okay, and this circles represent A, set A, and set B. Okay, so all the elements in set A would go in this circle here, and all the elements of set B would go in this circle here. And basically this point where set A and set B, this point where they intersect, I believe you guessed it, is the point where set A intersects set B, i.e. the elements you find in set A that you'd also find in set B. Okay, very important part of drawing a Venn diagram. So what are the elements that you find in set A that you also find in set B? I think we have 1 is common, and we also have 7. Okay, so the first thing we're going to do here is we're going to put those two elements, the intercepts of set A and B, we have 1, and we have 7. Okay, and then we're going to fill up the remaining elements in A. Okay, so we have 2, 5, and 8. Okay, I think that's all for A. And then we fill up the remaining elements in B, and we have 3 and 6, and I think that's it. Okay, now there's something else. There's one more thing, and students usually forget this, and it's a very, very important part. Remember, the universal set is 1 to 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1, 2, 3. There's no 4 at the moment, i.e. 4 is in the universal set, but it's in neither A nor B. So we just bring 4 over here, just right outside the circle. And that we also have 9. Okay, we also have 9 outside the set, and that is how you solve set questions using Venn diagrams. Okay, that's how you illustrate information using a Venn diagram. Okay, so let's move on to the next example. Okay, and in this example, we'd be learning to solve problems using Venn diagrams. All right, and basically we have a problem here, and the problem, it says, out of 30 candidates applying for a post, 17 have degrees, all right, and 15 have diplomas, and 4 have neither degrees nor diplomas. Okay, now it says how many candidates have both. Okay, now let's look at this. All right, and the first thing we need to do here is we need to construct a diagram to represent this information. So step 1, we have our universal set. Okay, and our universal set tells us everything. It's the overall, and in this case we have the universal set. We have 30 candidates applying for a post. Okay, so our universal set in this case is 30. Now we have 2 subsets of our universal sets. Okay, and we have one subset representing degrees, people that have degrees. We have another one representing people that have diplomas. All right, now we've been asked to find how many candidates have both. Okay, and the number of candidates that have both would be here. Okay, the point where the set of degrees intersect the set of diplomas. Okay, so we have candidates that have both here, and that's what we're solving for. So we bring in an x there. Okay, so we have an x here where the 2 sets intersect. Now the next thing we want to do is we'll try and fill up this degree set. Now we've been told that in total 17 people have degrees. Okay, so this whole circle is 17. All right, now this remaining part would be 17 minus x. Okay, so we have 17 minus x, and then for diplomas, basically we have this part representing people with diplomas, and we've been told that in total 15 people have diplomas, meaning this remaining part would be 15 minus x. Okay, and one thing, students usually miss this out. Okay, you need to remember that there are 4 people that have neither degree nor diploma. Okay, now we've constructed a Venn diagram. So what we need to do now is we need to solve for x, and to solve for x is actually ridiculously easy. Okay, it's a very, very simple process. We know that if you add everything up, everything in this set, if you add everything up, it should give you the universal set. Okay, so basically what we do is we add everything up. We say 17 minus x plus x plus 15 minus x plus 4, and that would give you 30, which is what we have here. Okay, and basically if we sum all of this up, you'd have that 36 minus x equals 30, and you have that x equals 36 minus 30, and you'd have that x equals 6, and x equals 6, which is the number of candidates that have degrees and diplomas. Okay, now let's move on to our final example, and this one is a bit it's It's a bit complicated, but it's not nothing that we can't handle. Okay, now the example says from a survey of 219 newspaper readers, okay, it was found that 181 of them read the Daily Times, okay, 142 read the Guardian, 117 read the Punch, and each read at least one of the three papers. Okay, now what this tells you is that there is no, in this case, there is nobody in outside our set. Okay, everybody is going to be in the sets. Okay, so because everybody either reads, each person either reads the Daily Times or the Guardian or the Punch, there's nobody that doesn't read any paper at all. Okay, so it then says that if 75 read the Daily Times and the Guardian, okay, so the intersect of the Daily Times and the Guardian, we have 75. 60 read the Daily Times and the Punch, intersect of Daily Times and Punch, we have 60. And 54 read the Guardian and the Punch, intersect of the Guardian and the Punch, we have 54. And we've been asked to draw a Venn diagram to illustrate the information and also find out how many readers read all three papers. Let's jump right into it. Okay, so the first thing we need to do here is we need to construct a Venn diagram. Okay, and we start our Venn diagram by drawing our universal set. Okay, and our universal set in this case is 290. Okay, we have E equals 290, and then we need to draw our circles to represent our sets. Okay, and basically we have the Daily Times, the Guardian, and finally the Punch. Okay, and then we'll start right here in the middle. Okay, this point is where the Daily Times, the Guardian, and the Punch, this is where all three sets intersect. Okay, which is the number of readers that read all three papers. Okay, and we just put an X there. That's what we're looking for. Okay, we have an X here. Okay, now the next thing we're going to do is we're going to look at the number of people that read Daily Times and the Guardian. Okay, so this whole place here, this area here, is the intersect between the Daily Times and the Guardian. Okay, and basically this whole place is 75. Okay, and then we're looking for this area here. This area would be 75 minus X. Okay, are you following? Wonderful. So the next part is we have the Daily Times and the Punch. Okay, and basically we know that Daily Times and Punch, we have 60 people reading Daily Times and Punch, and basically we have this whole area being 60, i.e. this area here would be 60 minus X. Okay, and then finally we have those that read the Guardian and the Punch. The whole area is 54. Okay, meaning this area here would be 54 minus X. Okay, so that's the second step. The next part we need to do is we need to identify what's in here, this area. Okay, now we've been told that 181 people read the Daily Times, so this whole circle here represents 181. Okay, now so far this circle contains 75 minus X, it contains X, and it contains 60 minus X. Okay, so if you're looking for what you'd have here, you'd basically subtract everything, 75 minus X, X, and 60 minus X from 181, because the whole circle represents 181 people that read the Daily Times. Okay, and basically this is what you have. You have 181 minus 75 minus X plus X plus 60 minus X. Okay, subtracting all of it, and you do the same for the Guardian. We have 142 people that read the Guardian. Okay, and we subtract everything here from the Guardian, and do the same thing for the Punch. We have 117 people that read the Punch, and we subtract everything we have here to have this. Now, how do we go about, I believe we're done with our Venn diagram. How do we go about solving for the number of readers that read all three papers? It's actually very simple, very straightforward. The next thing we need to do here is we basically just need to sum up everything we have there and equate it to 290. It's actually a very, very long equation, but I believe you understand everything that's going on here. You just sum up everything you have in the Venn diagram there and equate it to the universal set 290. So you need to be very careful when you're solving questions like this, okay? Because if you make a single mistake anywhere, you ruin the whole thing, okay? And it's actually quite prone to error. So take your time, okay, and take it easy. All right, so now when you have all of that equated to 290, you'd bring it down and you'd have 251 plus x equals 290. All right, and finally you'd have that x equals 290 minus 251, and in the end you'd have that x equals 39. Okay, so 39 people read all 3 papers. And that is how you solve questions like this using Venn diagrams, which brings us to the end of this lesson. Okay, and yeah, bye for now.